Hello and welcome to my presentation about ChatDoc, my project for this course where I implemented an end-to-end pipeline that employs QLoRA to fine-tune a Llama-2 model for medical diagnosis and doctor chatbot on AWS. The chatbot should be able to provide a medical assessment by understanding the patient's or the user's need, and should also be able to answer general questions about symptoms and diseases. Here a quick overview of the developed system, including the 5 interconnected components, the data collection with prominently the data factory, the training, the deployment, the web app, and the retrieval augmented generation. Each component can be started individually with a command line interface. The chatbot uses the 7 billion parameter model from the Llama family. The family itself consists of various pre-trained and fine-tuned LLMs, for example the LLM base, and also a fine-tuned version which is already trained on chat data. It goes up to 65 billion parameter models. It was trained on 2 trillion tokens with a context length of 4,000 tokens and outperforms any other open source model. It can even compete closely with ChatGPT and is available freely on Hugging Face. To be able to fine-tune such a big model, we employ the QLoRA technique. It builds upon the LoRa, the low-rank adapter technique, with which you only have to train so-called adapter matrices instead of the whole model. In QLoRA, these weights, these adapter matrices, get then quantized to 4 bits. QLoRA also introduces various other optimizations like a double quantization, a new data type, and also an overall more efficient gradient management. For my data collection, I had a strong emphasis on data quality and developing a modular and maintainable data pipeline that allows to easily integrate various types of data from different sources. For example, the official classification of diseases from the WHO, conversational data from healthcare websites, but also general purpose data. For our training, we leverage the AWS SageMaker environment, which provides the necessary computational flexibility and scalability as it provides a robust and cloud-based infrastructure. For our purpose, we use the G5X Large instance that features one NVIDIA A10G with 4 virtual CPUs and 250 gigabytes of local storage. Here we have an example answer to a real question I asked the ChatDoc. We can see that the model actually understands what the user asked and can provide a meaningful response, being Dr. Chat. My 3 main insights for this project are that data matters. This might seem obvious, but of how much an impact system prompts and the way you format, for example, conversational history has on the actual result was not very clear to me. Secondly, fine-tuning Llama-2 for a text generation model can easily result in overfitting. Adding task unrelated data helps the model to maintain some of its previous knowledge, also reducing epochs and introducing early stopping and checkpoints, working with them efficiently can result in better performance. Lastly, a comprehensive evaluation is very difficult, as qualitative evaluation is kind of important but is not scalable, and quantitative evaluation is difficult because you need kind of robust methods and the right data. Also, handling hallucinations or even detecting them is a big challenge. This is in a way addressed in our system by using a retrieval augmented generation system in a vector database. Let's have a look at the actual application. We are now in the developed web application. The main component on the right side of the screen is the chatbot component, where we can already see the greeting message from Dr. Chat, the chatbot, and an input field where we can ask our questions. The left side presents additional features. Besides the quick help section, we have a card that will display the best match ICD code plus a definition for the user's input. But let's try to ask Dr. Chat a question. I already prepared a question here. I'm coughing a lot lately and also feel pain in the chest every time I do so. What could be the cause of that? It takes some time to send the request to the Hugging Face Inference API, and then an answer is returned. That sounds serious. Have there been any other symptoms besides coughing and chest pain? Based on the question I asked, the best match definition from the International Classification of Diseases from the WHO was pulled up and is displayed here on the left-hand side, alongside with its match score and the actual ICD ID. And when we click on the ID, we get redirected or get directed to the official definition. Here it is MD 30.0, chest pain on breathing, which we can see does fit very well to the question. But let's go back to our conversation and answer no other symptoms like fever, cold, etc., just coughing and pain in the chest. Is it something to worry about? Again, after a short while, the model answers, yes, it can be a sign of respiratory problems, such as bronchitis or pneumonia. Would you want me to recommend some tests to diagnose the issue further? And we answer with, yes, please recommend a course of action. As we ask the model to recommend a course of action, it answers with, it is always a good idea to consult with a doctor if you're experiencing persistent symptoms like coughing and chest pain. However, based on information you've provided, it's possible that your symptoms could be related to a viral infection or other respiratory issues. Now it asks again a question, have you recently traveled or been exposed to anyone with similar symptoms? We leave it at that. We have a potential course of action, and if we would be interested in further exploring our symptoms, we could further engage with ChatDoc. Thanks a lot for your attention. Do you have any questions?